Hi guys, and welcome to grade 9 geometry. I am Mr. Habana Posi, or simply Mr. G, if that's too complicated for you to say out. And I'll be taking you through the syllabus as prescribed by CAPS. And I'm going to start right through in this video with a discussion on geometry, okay? And we're gonna take it slow from straight lines and build up to some complicated stuff, okay? So for now, allow me to take you through that, and I am going to show you what I have got set up here from GeoGebra. You can download the app on your cell phone, and you will be able to construct some of the stuff that you see in your screen now as I have constructed them. And let me just say also, I am doing this to upload on the YouTube channel, which we have created. You can just search together for RCITC as it appears on my video screen there, and you will find a series of these videos there. It will be nice, of course, if you will also subscribe so that any new video that comes up, you are notified and you are aware. Now, guys, let's start with some basic housekeeping stuff here. I'm going to start with a few definitions, okay? What is the difference between a line and a segment? Okay, in geometry, we've got names for these shapes that we have got, and we're starting with two basic things, okay? Now, if you look at this here, I've got something here labeled E and D there, if you will follow with this black pen on your screen. Now, this thing here called E is actually a segment, okay? It's a segment, okay? And this thing called D here is what we will call a line, right? So what is the difference between a line and a segment? Well, a segment has a starting point and an ending point, whereas a line has got actually infinitely many points on it, okay? As you can see, in this case, line D has only 2 points there, okay? I've not labeled them in this case. They do have labels. You could label A1, this one here A, you could label that one B, okay? But one thing that you should know about a line does not have a starting point, does not have an ending point. So what we're gonna do basically here, to be very clear with the vocabulary, in other words, the terms that we use in geometry, I will be basically constructing segments in most cases, okay? So I've got a segment here, segment PQ down here, so come with me here. I hope you see where my pen is writing now. That's where I am. I want you to concentrate there. And so if you don't want to use segment, if that's too much of a big word, then rather say an arm, okay? Okay, but it has got a name, it's PQ, because it starts on P, ends on Q. There's another one that starts on P, ends on S, another one on P, and ends on R, okay? So I've got 3 segments, okay? Now, whenever 2 segments join, okay, an angle will always be formed. Where are they joining? They are joining at a point. In this case, the point is P. Sometimes we say vertex, okay? Instead of saying point, we will say vertex. So let me label this one also for you, vertex, okay? This is called a vertex. So we've got vertex P, and we have a number of angles that are formed, actually. I can go ahead and label this thing here as P1. So I'm going to call this P1, and I'm going to call this P2, and I'm going to call this one here, or that goes around the 306.87. I'll call it P3, okay? So then we've got to give names to these angles, okay? That's another thing, all right? So we've got to give this names to these things. What are the names? So there are 2 conventions or notations that you can use to give names, okay? One, you can either use the difficult one or the complicated one, or you can use the very simple and brief method, okay? So I'll show you how to be brief, and I'll show you how to be complicated, but you are saying one and the same thing, okay? So you can just choose which way you want, but I'll obviously suggest you go brief, okay, so that you don't confuse yourself. So I can refer to these angles in a number of ways. One, I can say, well, guys, I've got here P1. I've got angle P1. I can also say I've got angle P2. And I can also say I have angle P3, okay? Which in this case, I know the value of angle P2, it is 26.57. I measured it. And I know the value of P3, it is 306.87 degrees. So that's it, right? If you want to be complicated, you can refer to P1 as angle QPS. Yeah, or you can even do this, QPS. You write a lot if you want to be complicated. Or you can refer to angle angle P2 as angle SPR. Or again, you can use that notation there. That's a little. You're still referring to the same angle. Or you can refer to angle P3 as angle QPR. Or if you like, you can say angle P, sorry, not P, I must start with Q as I did in the other one. If you pick that, very good. You follow me. So I can start with S and I say angle QPR. You are referring to the same angle. So I will be brief in most of the stuff, and where it is not possible to be brief, I will then use the complicated route, but I thought you should know this. Here's another thing that you should catch. We have now another nice word that we use is called adjacent, okay? So when something stands next to something, we say they are adjacent, okay? So angle P1 and angle P2 are actually adjacent. And this is why they are adjacent, because they share a common arm or a common segment, okay? So here's angle P1. It is formed between segment PQ and PS, and here's an angle P2 that is formed between segment PS and PR. So because they have this common segment, we say they are adjacent, okay? That's another important word that you guys have to learn. The first one is a vertex. This point here is a vertex. Second one, adjacent. Okay. Now, finally, let me wrap this up by bringing another nice word to you. Angles around this point. So in other words, if I'm going to take a protractor and try and measure this angle here from this line all the way around back to that line, I am actually going to get 360. And we say such angles form a revolution, okay? Because they give us an angle, a measure of 360. Now, given that, can you find angle P1? How would you find angle P1? Well, I just told you, I mean angle P1 plus angle P2 plus angle P3 should give you what? 360. So what should be P1? You know P2 is 26.57. You know P3 is 306.87. So what are you going to do? You're just going to say 360 minus 306.87 minus 26.57, and you're going to get 26.56. So that will be angle P1. That's the very simple way in which you can find an unknown angle when you have got angles around a point. And by the way, that's another thing. We say angle P1, P2, and P3 are angles around a point. Of course, we will say that if we do not want to say revolution. So again, you can always choose whether you want to be complicated or you want to be brief. If I want to be brief in this case, I will just say, well, angle P1 plus and angle P2 and angle P3 form a revolution. If I want to be complicated, I will say these are angles around a point. So you will see in geometry, there are a number of ways to say the same thing. You just choose which way do you want to go. Do you want to go the brief way or the complicated way? Guys, geometry is a language. So just as mathematics is a language, okay, so the thing about geometry is you will be communicating to the reader what you see, okay? You will be given a diagram with lines or triangles or what squares or parallelograms, whichever the case is. You will then be telling a story. What do you see in this square? What do you see in this triangle? Okay, so I'm going to take you through this journey and show you how to see things, okay, when you are given a diagram, what to pick up from whatever you'll be given. So guys, I hope you will tune in and join me as we go through this series of discussing geometry at a very basic and fundamental level. I try to keep this video as short as I can, and I hope you have enjoyed this. I'll catch you later. Cheers.